Good morning, everyone. Thanks for joining today's webinar, Complete Traffic Communication Systems with Intuicom. My name is Connor, and I'll be your moderator. Before we get going, just got a few quick housekeeping things we wanted to run through. All phone lines are muted. If you have any questions, please go ahead and use the chat feature within your GoToWebinar toolbar. Today's presentation will last about 40 minutes or so, which will give us time to answer all your questions at the end. And by attending today's webinar, you are eligible to earn TARP points with IMSA. For those of you who provided your IMSA number during the registration process, Western Systems will go ahead and handle that submission for you. And lastly, today's webinar will be made available for you to view anytime on demand. You'll receive an email tomorrow with a link to do so. And all right, with the housekeeping out of the way, I'm very excited to introduce today's presenters. We have Kenneth Gustat from Western Systems and Joaquin Siegel from Intuicom. Guys, floor is yours.
Okay, thanks, Connor. So I'd like to thank everyone for taking the time out of the day to join this presentation or webinar. I hope you find it informational. My name is Kenneth Gustat. I'm one of Western Systems territory managers down here in Southern California. And since we do have some new people joining the webinar, I have not had a chance to work with us. I'm just going to take a couple minutes to go over Western Systems, who we are, what we do, before I hand this over to JQ. So Western Systems, we assist agencies to solve traffic and congestion problems. We are headquartered up in Everett, Washington, been around about 20 years. That picture that you see there is our new state-of-the-art 30,000 square foot building. 60 employees, and we do service the entire West Coast. So as high up as Alaska, Washington, Oregon, Idaho, Montana, and my state here in California. Now, we are a proven market leader, and we do provide a broad product portfolio. But one of the things as being a relatively new employee at Western Systems, I only have about 16 months, is I think it's one of the most unique companies that I've ever worked with, and I think you will too. And in a good way, obviously. So one of the things I like about it is family owned, which makes us nimble. So if I need to call the owner to get something pushed over the hill, I can make that phone call. Try not to do that too often, obviously. With over 20 years experience, we have a depth of talent and resources that is actually unrivaled in the industry. We are a one-stop shop too, so we can provide innovative and custom solutions. But most importantly, it's the culture of Western Systems. I've never worked with a more passionate, dedicated, and most importantly, a fun team. I think that's why Western Systems has actually been so successful, is they are always trying to understand their customer and going the extra mile. Now, at Western Systems, we are a manufacturer of cabinets. So we manage the 33 series cabinets. We do ATC. We do P or NEMA. We even have a patented NEMA cabinet. We call it P+. And as you can see in this picture here, it has a built-in UPS system, and then the batteries are on the side. So we're separating the UPS, and you can access the batteries separately. We're keeping the heat out of the main cabin, and as you know, heat does kill your equipment. We can also do custom cabinets. So, for example, the city of Anaheim, rather than have a battery backup system, they had us build in a custom-built fiber hub location there that's just completely accessed separately. Now, we are truly made in the United States. All our manufacturing is in the United States. And I believe we're the only cabinet manufacturer currently that's still in production because we don't have our facilities or manufacturing in Mexico. Now, Western Systems can provide everything in the intersection. We only partner with the best of breed manufacturers. For example, Siemens for controllers and connected vehicles, Alpha battery backup systems, signage, pedestrians, signals, cameras, you name it. We can provide a solution for it. So there's a lot of dots to connect, and that's where we really like to come in and assist. And that's why I'm very excited about having JQ join us on today's presentation. He's bringing over 20 years experience just in wireless alone. So thank you, JQ. I'm gonna go ahead and hand this over to you. Give me a second, or you can go ahead and take control.
Sure, I can take control here. A second, just let me know if you can see my screen. Everything should be fine now.
Good to go.
Hello, good morning, everybody. Good afternoon here from Houston, Texas. I hope everybody's having a great time, and thank you so much to Western for inviting me to be part of this event, this webinar. So I'm going to be talking about Intuicom. What we do is we provide wireless solutions, and I am in charge of the ITS group. We are a company that's been around for over 20 years now, and we actually have presence all over the world. You can, oh, sorry, having some issues here with my screen. Oh, all of a sudden, sorry about that. There you go. Okay, now I can see you guys.
Great.
So we have solutions installed in every single continent in the world, whether it's in the Sonora Desert or the Antarctica, Europe, Thailand, Asia. We actually provide wireless communication solutions for people all over the world. But again, one of the important things that we do here at Intuicom is that we specialize on ITS. We provide complete communication solutions. We are not just tailored to bring you a radio or a box. We actually want to hear what you guys are doing out there so we can provide you with the ideal solution, the ideal type of communication that you need in order to bring all the data from all your intersections or highways into whatever you want to send it to. We are recognized and we are well known in the industry, not only for the type of products that we have, but also for the support that we provide. I mean, we are one of the few companies that like to have a warm body answering the calls or responding to your emails. We are not shy to reach out to you guys. Please do not be shy to reach out to us as well. So what we're going to be talking about here today is not just our products per se, but also all the things that we bring to the table. Intuicom, on top of manufacturing wireless solutions, we also help everybody at the intersection from the get-go. If you need a link study, if you need us to design your network, if you need a complete turnkey solution for your intersection, everything that has to do with communications, everything that has to do with networking, bringing your products in, that's what we're here for.
I got a question for you.
Of course.
On network design, do you have an example of how you were able to assist a customer with a network design or one of those scenarios?
Absolutely. Actually, that's a good question during this presentation. Later on, I will be talking about a particular example of something that we did here in Texas, actually, in the city of Amarillo, and I will walk you through how we helped them design the intersection so that their system was working 100%. Good question. Thank you.
Thank you.
All right, so let's jump right into our products. As I mentioned before, we've been around for more than 20 years in the ITS. I remember the very first intersections that I was bringing on and communicating were using the good old FScape to 100 baud. Some of you guys will know what I'm talking about. I guess I'm aging myself already. And we were bringing the intersections by interconnecting via copper, doing the uploads and downloads. So we started with what we call now our serial or contact closure line. And what this line of products do is they bring what we call legacy devices or devices that are still using serial, DB9 connectors, that sort of thing. What we do here is provide a connectivity, for example, to 170 controllers, 2070 type of controllers, or any device that still uses a serial port in order to get connectivity. We're also using very traditional way of bringing wireless, which is the 900 megahertz frequency. Some of you guys will remember one of the very first phones I use at home actually use the 900 megahertz band. And the reason we like the 900 megahertz band, or the reason the 900 megahertz band was ideally for traffic back in the day when we started doing this, is because the technology was designed by the US military, actually. So what you could do in the 900 megahertz band is you can hop through it. The radios are called frequency hoppers. And by hopping, you are doing a number of things. You can, number one, avoid interference. And number two, being able to get a really long range because you are not only as I said before, avoid interference, but you're also able to hide yourself from interference or hide yourself from people that might be wanting to listen to what you're transmitting or the data you're transmitting through the air. So that technology was adopted. That was the very first technology that we used for traffic. And to this day, a lot of people are loving the flexibility that the 900 megahertz frequency hopping spectrum, that's what we call it, technology brings to the table. Now, if you can see on the screen right now, we have, I'm showing two types of units that use this particular technology. One of them is called a communicator 2. That one is exclusively used for serial communications, uploads and downloads controllers. That would be ideal. And the other one is used for contact closure. What I mean by contact closure is you do a remote on and off. It's got a digital IU inputs and outputs, and we're actually going to be talking a little bit about applications that you can use with this little guy. But before we go into that, I want to talk a little bit about a radio that we just released last year. And this product, what it does is a perfect way to bridge the legacy technologies with the IP. Nowadays, everybody's jumping into IP. Everybody's going network. We no longer see, or well, we see less and less coax out there. We see more and more Cat5 in our intersections. So what we decided to do is bring the advantages of the 900 megahertz frequency hopping spectrum technology and add to it the advantages of the Ethernet IP networks. And the way we do that is with this product that I'm showing here on the screen. As you can see, it's got 2 serial ports and 2 Ethernet ports. And the beauty of this product is that you can actually use them as you see fit. You can get data inside in as serial, outside as Ethernet, or inside as Ethernet, outside as serial, inside as serial, outside as serial, inside as Ethernet, outside as Ethernet. So you can use it as a perfect bridge to bring all these devices that you have out there that are still using serial communications and you want to bring them up to the future, to an IP network. The easiest thing to do is just bring one of these little guys to the intersection, plug your serial ports to it, and then your Cat5 out at the other end, and you are good to go. You all of a sudden, you are now part of an IP network, whereas you used to be a serial port. So Kenneth, I believe you have a little bit of example of how we use this type of technology.
Yeah, thank you. So we use the contact closer radio to solve a unique scenario in the city of Samash, Washington. So if you see on that map there, this is a double blind turn on a T intersection. Additionally, there's also a hill, so you got cars coming down at a speed. So basically, you look to the left, you clear, you look right, you're clear, and then you pull out and there's a car on top of you. So it's a very dangerous intersection, and the community was not too happy. They want to make some changes to it. Additionally, the city couldn't run fiber, and there was an H system. So if you move to the next slide, sir, please. Okay. So we came up with a combined product solution. Not only was it inexpensive, but it dramatically increased the safety of this intersection. So we used a radar, you can see in the blue there, to detect the oncoming cars. And then with the contact closer radar, we wirelessly activated the flasher. So locomotors now could be notified if there was a car coming. The city was quite happy, but most importantly, the local community and motorists were happy with that solution. Thank you, JQ.
Thank you, Kenneth. So as Kenneth was saying, it's a perfect example of how to use technology. Now, remember, I was mentioning that this radio uses a technology called frequency hopping spectrum. The great part of this technology, as I mentioned before, is you can avoid interference. And not only that, but you also have a little bit of water penetration. So one of the good things about using this type of units is the fact that you can literally shoot from the hip. You don't need to aim antennas with a specific detailed tools, or you only need to have a general idea where you need to be pointing at, point your antennas that way, and off you go, off to the races. And as Kenneth was demonstrating here in this example, that's one perfect application. Now, this radio that we're showing right here is not only for one contact closure, as we're using it here. Well, in this case, two. It has all the way up to 8 inputs and 8 outputs. So, and you can map every single one of those inputs and outputs the way you see fit. So you can, for example, add a confirmation to it, or you can tell a radio, hey, if I get confirmation that you are turning on, please turn this other flashing beacon that is down the road on as well. Or you can send it to flash. Or once you get the guy that we say on flash, you can get confirmation that the other guy was getting flash, and then going back to original one to get confirmation of the confirmation. So you can go crazy, but you have a lot of possible combinations, 8 inputs, 8 outputs. All of them can be mapped the way you see fit. As you can see on the screen right there with the little LEDs, you'll get idea of the unconfirmation of all the communications that are happening, and they're on your digital inputs and outputs. So that's what we call the, again, legacy serial technology, contact closure radios, serial radios, and a bridge between serial and IP. Well, let's talk a little bit about IP. See, once you look at the intersection, I want you guys to remember the type of technology that we have an intersection compared to what we have, let's say, 5, 10 years ago. 10 years ago, what we were worried about were uploads and downloads of controllers. We were worried about maybe sometimes UPS data. We were talking about conflict monitor, that type of data. However, nowadays, we have video detection cameras, we have adaptive systems, we have a lot of information, a lot of data gathering, the Bluetooth devices, et cetera, that is happening at the intersection. So the need for bigger and more capabilities to bring all this data just keeps evolving. So what we have done is we have evolved as the needs of the intersection have grown, our products have also grown. So we've come all the way from bringing connectivity to, from 1200 baud all the way to gigabits. So in this case, last year, we released a brand new series of products, what we call, they're part of our broadband family of products. This particular one that I'm showing is the family called AXIOM. And what the AXIOM radio is, it is a broadband radio that is exclusively dedicated to IP. And one of the advantages that our products have is the fact that once you get one of our radios, one of our broadband radios, that one radio can be used as a repeater or as a master or as a remote. You don't need to have different type of equipment in order to bring all the functionality that you need at one particular intersection. However, one thing that we want to do is make it really easy for everybody, really easy for you guys to determine what you need to do in order to determine which type of broadband you want to, which type of broadband technology, you want to bring to the intersection.
I got a question for you, Joaquin. You have the different frequencies. I get this question a lot. What's the benefits of each one, and maybe drawbacks with going with the 3 different frequency choices that you have?
That's an excellent question. So you decided that, or you need your intersection, and then you need to know what type of frequency you are going to use, because you want to communicate all the data that you have in your intersection. You want to send it somewhere else. That's basically what we do, right? We are kind of like what United, Delta, American Airlines do. They move people. What we do here in Intuicom is we move data. Now, in order to move data, that's a great question that we need to help you determine which will be the best particular frequency that you need in order to bring that data from one point to the other. Now, our radios, our broadband radios, you can always have them in 3 different flavors. The 5.8 gigahertz band, the 2.4 gigahertz band, or the 4.9 gigahertz band. Now, the advantages or differences of the technologies is the following. you guys remember when you started to having Wi-Fi at home, right? You started installing the very first Wi-Fi routers, and you were able to bring your computers and your laptops and all these other devices into your home network. Well, you were using 2.4 gigahertz technology. That was the very first Wi-Fi technology that was used. So 2.4 was in a way the pioneer. We are bound by the FCC. So the FCC rules with type of technology that's been opened up, the type of spectrum that we can use. Now remember, we are operating on the free spectrum, so you don't have to have a license to start using these radios. So because of that, and because of the FCC regulation, the 2.4 again was the very first band that we started using. Now, the great thing about the 2.4, of course, was that it opened up the Wi-Fi for everybody. The bad thing about the 2.4 band is the fact that, well, everybody can use it. Right? Everybody's using all the time, and unfortunately, that popularity of the advantage of using the 2.4 caused the 2.4 band to become saturated. So as you were going to intersections, first there was a clear communication happened, there was no problem, no interference, and as people started to bring in more and more products into that band, all of a sudden your frequency spectrum, or the bandwidth that you have in that particular frequency just got reduced. So next thing we do is we actually came up with, or the FCC allows us to jump into the 5 gigahertz or 5.8 in this case gigahertz band, which is a band that allows us way more flexibility. The bandwidth is higher, the bandwidth is bigger, and you have way more capabilities to select the channel you're going to use, and you can avoid frequency. So is the 2.4, sorry, is the 5.8 going to get saturated? Probably. Actually, I've seen it in some cases, so it's going to go the same way as the 2.4. However, the FCC allows us to also have products in the 4.9 gigahertz band. Now, the 4.9 gigahertz band, that one is, well, never say never, they say, but it's unlikely to get saturated because that one is reserved exclusively for safety. So traffic, EMS, fire departments, they're all able to use that particular band, the 4.9 band. So if you go to an intersection or one particular location and the 2.4 is saturated, the 5.5 is saturated, you can always try the 4.9, and the odds that the 4.9 is going to be saturated are really low because, again, it's reserved only for safety applications. So 4.9 is a great use of the band or communication, sorry, when you have you might have conflicts with other ones. So again, 2.4 is great for Wi-Fi. 2.4 is great for example, when you're trying to provide Wi-Fi in, say, for example, downtown, and you want to provide people with Wi-Fi access in one particular area. Well, 2.4 is the one that a lot of people use, or the most common one, so it's easier to just allow everybody to use 2.4 for that particular application, and then you can use the 5.8 to communicate your radius. And I'm digressing here a little bit on applications. Let me just go back to the radio itself, so I explain what I'm talking about. The radio that I'm showing here, I don't know if you guys can see the camera well, but I have an actual radio so you guys can see the size of the units itself. So this radio, the advantage of using this radio is the fact that you have the radio and the antenna all integrated in one device. So that means that all of the energy that the radio has inside is being broadcast without any loss, like when you use coax cable and things like that. So all the energy that the radio has inside is just being broadcast immediately out to your intersections. Now, this radio comes also with GPS, like you can see right here on the top. And the great thing about the GPS is once you install that radio on intersection and it's got a GPS unit, you can go to your software, you open up your software, and all of a sudden the radius will be populated on your map. You don't have to drag and drop or try to look for the coordinates of where the intersection is or where the radio is, it immediately gets populated. So that is one option that we have is an integrated antenna. And again, it comes in 5.8, 2.4, or 4.9. You can get up to 300 megs of throughput. And the advantage also of the antenna is that we have a dual polarization antenna. So in reality, it looks like one antenna, but we actually have two antennas here. One of them is shooting on a vertical polarization, and the other one is shooting on a horizontal polarization. So that allows us to go all the way up to 300 megs of throughput on one radio. Now, let's suppose that you have a intersection that is great because you are going to be using it with this type of antenna, but you have another intersection that is far away or is behind it, and so you can't really aim at it, or you have a corridor that is facing north and you have the one intersection that is facing south. How are you going to be able to shoot to that guy that is aiming, that is at the other direction, right? Well, the easiest thing to do then is, instead of having an integrated unit, you can see on the screen right now where we have something we call external unit. So what you do with this external unit is you will, instead of having an antenna integrated that we have on the previous one, you will have two connectors you can see on the screen right there. And what you do is you have some coax cable attached to it, and then you can have a directional antenna. It could be a panel, it could be a sector antenna. Sector antenna are the ones that you see when you're driving down the street and you see some cell phone towers. You'll see those elongated kind of rectangular antennas. Those are called sector. So you can have a sector antenna, you can have a Yagi antenna, or you can have an omnidirectional antenna, which is basically just a pipe. And that, for example, the omni gives you a 360-degree radiation pattern. The panels give you about 10-degree radiation pattern. Sector antenna gives you 30, 45, 90 degrees, depending on the shields that you add to them. So when you're trying to reach out to intersections that are not in complete line of sight, that are not within your 10-degree parameter or 10-degree radius that the panel antenna gives you, then that's when you go to an AXIOM external unit, and then you just hook the antenna that will be ideal for your particular application. So recapping the AXIOM line, you have the choice of integrated or the choice of external. And within integrated and external, you can either go with 5.8, 2.4, or 4.9. Now, these are all single units. Now, we also have dual units. Remember the example I was giving before where, so you want to, for example, have the same radio being able to communicate your intersections and at the same time providing Wi-Fi to people that are nearby, say downtown or that kind of application. Well, you can absolutely do that with our dual radios. So in this case, I have a picture that's showing you guys an AXIOM unit that has an integrated antenna. And let's suppose that integrated antenna is being used to communicate all the intersections. And then at the bottom, you'll see two coax connectors. Those two coax connectors allows you to, for example, set up a couple of omni antennas underneath. And with those ones, you can provide Wi-Fi. Now, what is happening inside the radio is you have two units. One radio unit with 5.8 shooting, communicating with all 5.8 units downstream, and another unit, a 2.4 unit, providing Wi-Fi to that particular location. And of course, you can mix and match as you see fit. You can have a 5.8, 5.8. You can have a 5.8, 2.4, 5.8, 4.9, 4.9, 4.9, 2.4, 2.4. I mean, you can as many combinations as you want. It's really easy. The box always looks the same. The only thing that changes is inside the type of radio that we're using here. And now, because we're able to bring two radios, then we are doubling up, aggregating the bandwidth, and so you can see that instead of going 300, now we can go up to 600 megs because we are bringing the two radios into one unit. And here's another example. What if you don't want to have an integrated antenna? You want to have 4 antennas going in every direction? Well, you can do that as well with our AXIOM dual external units. And exactly as the one that I mentioned before, instead of having a directional antenna, you'll have 4 types of antennas, and you can point those antennas anywhere you go, 2 radios inside, and again, all possible combination. Now, one of the advantages of these units is the fact that we actually have indicators here. You'll see not only that the radio is on, but you also see the signal strength. So as you are moving the radio with antenna, you will be able to see how strong your signal is. And if you have a dual radio, it will also show you how good your connection is on both radios. So it will first show you signal strength in one direction, and then it will show you the signal strength for the other dual radio, which is another thing that nobody else actually can replicate here in the industry. Anyway, so that is the AXIOM product line, the regular AXIOM. Now, this year, actually, we have, again, continuing the topic of bringing more and more data. Well, the FCC has opened up yet another way of bringing even more data. So they call it the 802.11ac. I don't want to get too technical, but basically what it is they just allow us to use more spectrum and bring you even more capabilities. So all the capabilities that we talk about in the AXIOM, the GPS, the signal strength indicators, the power LEDs, the flexibility of 5.8 or 4.9 bands, all of that, plus more bandwidth is now part of our AXIOM AC line. So if you can see right there on the screen, the AXIOM AC will actually go all the way to 866 megs. So if you have 2 radios in there, you are now talking about gigahertz, right? 1.7 gigs of throughput, available throughput. Now, if you notice there, we do not have a 2.4 offering for the AXIOM AC line. And the reason we don't do that is, remember, as I mentioned at the beginning, the difference between frequencies, the 2.4 is just not wide enough. There's not enough space in the 2.4 frequency to provide this much bandwidth, right? So on the AXIOM AC, you have 2 choices. You can either go with a 5 gigahertz or with a 4.9 gigahertz unit. And again, you can also do the dual, where you can have combination of both, and you can do a dual external as well, right? Now, any questions so far? Okay.
We'll do the questions at the end.
Thank you. So that's our AXIOM product line. Now, I also want to talk to you about another product line that we have, and this is more like economy line. We call it the VVX. Now, the VVX line brings same throughput as the AXIOM single, which 300 megabits of throughput. Now, on this one, you don't have a GPS unit, right? That's one of the main differences, right? And also, you don't have the capabilities of bringing a serial port. With the AXIOM, you do have capabilities of using a external serial port for, you can connect it for, say, for example, a PTC camera, or you want to bring some more data from a particular serial device. You have that capabilities with the AXIOM. With the BBC, you have the same blessings that you have with the AXIOM. You don't have the GPS and you don't have the serial, right? That's why we call it the economy line, but you have all the advantages that you have in the AXIOM as well. All right. So I want to talk a little bit about, there was a question that you have kind of before about design and how we help people and whatnot. Well, let me jump into it a little bit here. So what I have here is an example of the things that we try to help everybody with deployments before you even acquire one of these units. We really like to help you guys to determine if the link you're trying to do will be a successful one. So what we're looking at is a real case scenario. It's a city of Amarillo here in Texas, in Amarillo. What they were trying to do, they actually have been using some other wireless technologies or weren't trying to use wireless technologies for a while, and there were a lot of intersections where they would just couldn't get connectivity going. And so what we told them is, well, reach out to them, and we asked them if we could help them with a topography study. And we did that from our offices in Boulder, Colorado. We didn't have to go to Amarillo because we have software that actually has elevation from all over North America, and we can do the simulations from our office. And they told us that they didn't see any problem because Amarillo is a very flat city, or at least it looks like a very flat city. Well, once we did the analysis, and I don't know if you can actually get to see that there was. Let me see that on the left side of the screen. There's a transmitter right here, and we're trying to go to the other side of the screen right here. And if you can tell, the way the radios transmit is not like a laser beam. It's more like a football shape. I'm going to exaggerate it here, a football shape. So what we always recommend the people to do is try to get the radios installed as high as possible, so that you are not interfering with yourself and losing some of your energy down on the ground. So if you can see right here on the screen, there was a couple of hills that were causing an obstruction, and that was the reason why people in Amarillo, Texas, or the guys in the traffic shops in Amarillo, Texas, couldn't really get those other wireless products going. They didn't really know that there was a little bit of the elevation happening there, and although the city looked flat, there was something they needed to do in order to avoid those little hills. And this, by the way, this zone, this football-shaped zone, it's called Fresnel zone, and you can see the word right there, wash Fresnel. So what we did is doing the calculations. You can see the calculations. There is a formula that we did, and based on the formula, we actually helped them design their intersections in a way that now all of a sudden everything got installed and everything was working without problem. So that was one example of the things that we can actually do for everybody, for link studies and topography, things like that. Please do not hesitate to give us a call. Now,
I love the football analogy. You don't think of it like I always try to think of it like a laser. So that's good.
Thank you. Well, as I said, well, now once we talk a little bit of hardware, what I want to talk a little bit is about other thing that makes us completely unique, and that is our software. See, I've been in the intersections, and radio is really not that simple. I mean, there's a lot of handshakes that needs to happen. There's a lot of negotiation. There's a lot of things that the technology needs to bring in order to be able to get your data from one point to the other. So what we are committed to do here in Intuicom, especially on the ITS end, is to come up with a simple way of programming the units, making sure that whomever is going to be at an intersection is going to be able to bring all the communications to a location. And what we're trying to do, of course, also is try to avoid people trying to go to places and sites and go back to the sites and realign and those kind of things. So we try to make it very, very simple. So in order for us to do that, we actually came up with what we call Broadband Pro. And this software makes the configuration of any of our units the easiest one that you can actually find anywhere in the industry. One of the things that we like to do is to make sure that you guys have all the information that you need in one screen. You don't have to look at tabs. You don't have to jump around and see if your one radio is being able to talk to the other, communicate. No, all the discovery, all the configuration, all the control and monitor of the units are done on one screen, and you can at a glance look at, say for example, I got here a screenshot of all the things you can do with our software. Right? You can get your unit name. You can get the actual color changes. So you can see all these are green lines because that means that you have a perfect connectivity. However, if you don't have the best connectivity, if you're losing connection or link, it will change from green to amber or red. And you can change the parameters yourself. You say, well, you know, when I have 100% of data is going to be green. When I have 99% of data is going to go yellow. Or it could be when I have 50% of data, going to go yellow. Depending on whatever you want to do, you can customize it as you see fit. Right? You can just double click on any of the units, and the unit will immediately pop up, and you will be able to configure. You'll be able to see how the connectivity is. You'll be able, who is this assigned to. You are able to configure alarms. You can see how your transmit and receive data is going. You can see how your signal strength is. This is good, it's better. The type of packages you are. You just hover through a radio, and all of the information that you need for all of your units is right there for you. But we didn't stop there. We actually took it to the next level. And if you can see right there, I have an example of the way it looks in networking. So if you want to generate a report of every single one of the units, and you want to visually see how they are connected to each other, you have a visual representation of how your network is being set up. We introduced a dark theme this year, which I personally like a lot. Sometimes you have a lot of glare, a lot of white in some softwares out there. So, but you can always choose the dark mode. You can see right in my screen the difference between light and dark. You have the information on both. Same information, is just a different way to visualize it. Also, we came up with something unique that people are trying to imitate nowadays, which is our reporting capabilities. You can create a report, generate a report for every single one of your radios. You can export it as a PDF. You can export it as an Excel file. Some people are using those as signal performance metrics, because it gives you not only the transmission rate, but if there are any errors and any type of deviation from the regular link, you can have it in reports. And we also are able to generate alarms. So you can generate alarms too. So when your connectivity is not optimal, or your connectivity goes down for whatever reason, or a link goes down for, say, somebody crashed into a pole and the radio is no longer transmitting, you can set up the software so you'll get an email notification alarm, and you can you can work on any type of information that you need required from our software. So any questions so far before I keep going?
No, that's great. That's great information. That's great information. Hold on here. I'll take over the screen here.
Okay.
It'll let me. Yeah, sorry, switch the screens. Bear with me. That's great information, JQ. I really appreciate it. I think we're going to move to questions. A couple things. You raised the bar with that PowerPoint presentation, by the way. It's the best one I've seen so far with all the graphics. So thank you for the information. Connor, I believe you have some questions that have come through.
Yeah, I do. So we can get going on the Q&A process. We had a few come in while you guys were speaking, but for those on the line, if you have any questions, please use the chat feature within your GoToWebinar toolbar to go ahead and ask those. So a couple here for you guys. The first one is, can you tie in your products to a cell phone network?
Oh, that is an excellent question. Yes, absolutely, you can. Actually, part of our solutions, as I mentioned, the software, which, by the way, I neglect to mention the fact that all of you guys can download that software that I was demonstrating today, and you don't have to pay a license for it. We have available in our website. You can go to Intuicom.com and just click on the broadband software, and you will be able to get a copy of it. And once you download it, you will be able to see a new feature that we just added that is called port forwarding. So what we do with port forwarding is, suppose you have a cell phone network, or you have a radio network, and you're trying to bring another part of the network, another device, and that device is out there in the boonies. You need to have a cell phone modem in order to bring that information. Well, it's really easy in our software. You just go to port forwarding, you get your IP settings from the router that you're trying to access, and all of a sudden you will be able to see in our map, the map that I was showing before, you will be able to see that as part of your network, as part of your communication. Now, you will not be able to program it, of course, because it's not one of radios, but you will be able to see it on the map, and you'll see that from that point on, it is just a cell phone network. Now, one word of caution, though, when you use a cell phone is the fact that once you abandon our network, we're forwarding into the mobile network, you lose all the safety features that we provide. Our encryption is military grade, is the highest that you can possibly get. So if you're gonna jump into a cell phone network, you gotta make sure that the guys that are working IT are able to maintain all the encryption and the security settings that we provide with the radios downstream on your mobile networks. Hopefully that answered the question.
Great job.
Great. Next question for you is, I'm not a radio expert, so how do I know which products to use for a specific application? For example, regular uploads/downloads of controller data.
Right. Another great question. Well, as I mentioned before, controller uploads and downloads, I would recommend using DBX. But I guess the real answer to that question is, give us a call. We love to get involved from the get-go. We have last count is about 35 different types of radios available for you guys, and we don't want to push one radio just a forever application. On the contrary, we want to hear about the application that you have, and then we love to suggest the type of units that you will need for that particular application. For regular uploads and downloads, and I say you're only using 2070 controllers, I would recommend, for example, the EBX. If you are trying to bring video, for example, or a lot of CCTV, I would recommend an AXIOM AC. So you don't have to be a radio expert. We are here to help that. So give us a call, give Western a call. I mean, we're not shy on that regard. So we love to help you guys with the design. Let us take the brunt of the design, or so we can suggest the real wireless solution for your application.
Next question for you. How many remote radios can use a single point as a hub to a network, such as fiber optics?
Well, you can have up to two, well, because it's IP, so I assume you're talking about IP, you're limited to 255 on the same network. And you can add on, create a subnets and things like that, but up to 255 is a good solid number. I'll go with that for IPs. Now, if you're talking about frequency hoppers, remember the legacy devices, that changes. You can have up to 2 repeater levels, and each repeater will, I wouldn't go more than 20 per. So again, if you're using I'm talking about copper connectivity, but so for IPs, 255, for legacy devices, the largest that I've done myself is without repeaters, was 150, something like that. But if you add a second repeater, I wouldn't go more than 20 on that particular leg. So 255 for IP, 150 for legacy.
Thanks for asking that question. Actually, we were actually having a sales team meeting yesterday, and that came up. So thank you for clearing that up for everyone on my side.
Right, and it really comes down to design, right? And the way I said 255 is because you are limited by the your optics, right? You 192, 168, 0, 0, right? So you can only go to 255, blah, blah. But again, that's it's all about design. So the limit, the sky's the limit, really. Again, it comes down to design. Will help you design the way to optimize your network.
All right, looks like one last question for you here. It says, is it possible for Intuicom radios to talk to other manufacturers' equipment?
Yes, absolutely, you can. Again, because we're bound by the FCC regulations, right? So I mentioned 802.11 a couple of times, but really, when I say Wi-Fi, 5.8, 802.11ac, all those are regulated by the FCC. So you can do a couple of things. You can change the settings to match the settings that we have based on the FCC parameters for 802.11. Or if you're using a proprietary protocol, we actually are able to talk to at least 2 or 3 wireless manufacturers that use some proprietary protocols called Endstream is one of them. Companies, I guess I should use the name, Encom, Proxim. We're able to tie into those brands. Again, we just need to go to or help you guys with the design, explain you what you need to do, and then you can definitely talk to other radio manufacturers. Now, when it comes down to frequency hopping, that's different though. That's there's different things you need to do, but broadband IP easily, sure.
Got a couple more questions come in. If 20 devices are connected, how much bandwidth does each radio receive?
Well, the radio actually is not, it's talking on a polling scenario, right? So it's not receiving everything at the same time. So it will receive 100% of all the 20 every single time, right? One at a time, I guess. Does that answer the question? Remember, it's a polling scenario. So you are not segmenting the band. So the master, or what you program as a master, will talk with one remote radio, get 100% of the data at whatever throughput you have programmed, and then you go to the next radio, and next radio, next radio, next radio.
And the same, in regard to that same question, comes in and says, streaming video bandwidth.
Right. But what is the question? How much bandwidth?
It was the question before the 20 devices connected. Yes. So
right. I mean, I just used the nice round number 20, but again, it depends on a number of things. Like you're bringing the video, is it encoded? Is it H265? Is it analog? Is it digital? It really depends on the type of video device that you are using. Once you determine the video device you're using, then you need to determine how you are going to send the data and the type of radio you're going to use for that. Now, my recommendation for using video, more than the radios itself, more than the cameras themselves, is make sure that you are not using broadcast, that you're not trying to bring all the video at the same time. Sorry, it's multicast. Multicast is called, sorry, multicast. Because when you use multicast, every single one of the video cameras you got out there are trying to talk to radio or talk to every single device that is out there. So you can flood your network by doing so. So if you are going to use cameras and your cameras only use multicast, again, give us a call and then we walk you through how to program not only our radios, but also the video cameras you have in the field in order to have the best possible bandwidth for your data streaming or for your video stream. Now, if using analog cameras, again, that gets into another topic. You need to get encoders in order to make it convert in digital. And again, we will definitely help you with recommendations on how to program the encoders you already have, and also how to set up your particular modems. For example, I know that if you're using a Cisco modem, you have to go to particular settings on that Cisco modem or to make sure that the radios are able to communicate with every single device that is out there. Again, one of the things I would like to do is know exactly what you guys are doing, know what ITS is, and get to the nitty-gritty, help you specifically with the type of application that you have.
All right, looks like one last question for you is, how would you bridge fiber?
How do you bridge fiber? Well, there are a couple of things. Of course, if you're bringing fiber, assume you already want to have a lot of data. So you'll have to bring a fiber modem, right? For modem so you go from fiber to Ethernet, and then from Ethernet using a radius, you get Ethernet at the other location, and then you get another modem switching from Ethernet to fiber at the other end. As a matter of fact, that was the very first Ethernet link that I made in my life. I did it in the birthplace of Ethernet in California, actually, in Joaquin Valley. And I was in Silicon Valley, and what happened in Palo Alto there, sorry, it was not Silicon, Palo Alto, sorry, is that they have fiber everywhere, of course, but there were some locations where they have train tracks in one, and there was another when they have a lake, and they just couldn't get fiber to it. And that's exactly what we did. We just had fiber modem, sorry, at each location, switching to Cat5 to Ethernet, and then we just jump using our radius. Done.
All right, great, thanks. Thanks, Kenneth. Thanks, Joaquin. Thanks everyone for joining, and have a great rest of your day.
Well, thank you very much. I appreciate it.
Thank you. Thank you, JQ. Appreciate the effort and energy put in. And also thank you for bringing that amazing hat to the conversation. I have to get one of those. Change your name to GQ.
Appreciate it. Thank you so much, guys.
Thank you, everyone.